this module, you will learn about Zener diode and its function as a voltage regulator. We know that if we connect a PN junction diode to a battery with the P side connected to the negative terminal and the N side connected to the positive terminal, the diode is said to be reverse biased. A reverse biased diode allows little or no current through it. According to the IV characteristic of a PN junction diode, the current through a reverse biased diode changes very little with an increase in applied voltage, and it remains almost constant. The value of this current is called the reverse saturation current. Let us see what happens when we increase the applied voltage across a reverse biased diode after it attains the reverse saturation current stage. We observe that the current through the reverse biased diode suddenly increases for a specific value of applied voltage. This phenomenon is called breakdown of the diode. Diode breakdown occurs because a high applied voltage creates a strong electric field that results in the breakage of covalent bonds in the P region. The electrons released by this breakage of bonds have enough energy to enter the N region, resulting in a large increase in current through the diode. The emission of these electrons from the host atoms due to the high applied voltage is called the internal field emission or field ionization. The voltage at which there is a sudden increase in current in a reverse biased diode is called the breakdown voltage. A diode designed to have low breakdown voltage under reverse bias is called a Zener diode, which is named after its inventor C. Zener. A Zener diode is made by doping both the P and N sides of a PN junction diode heavily. The circuit symbol of a Zener diode is represented as shown. Although it is similar to that of a PN junction diode, the major difference is that the two small projections in opposite directions are added to the line on the N side of the PN junction circuit symbol. The pointed edge of the triangle indicates the N side of the diode, and the base of the triangle indicates its P side. Beyond the breakdown voltage, even an insignificant change in the reverse bias voltage can produce a significantly large change in the current. This implies that the voltage across the Zener diode remains constant, even though the current through it varies widely. Thus, a Zener diode can be used as a voltage regulator to convert a variable voltage input into a constant voltage output. Here is a simple circuit used for converting a variable voltage input, say, from a rectifier into a constant voltage output using a Zener diode. The input voltage is connected to the Zener diode through a series resistor having resistance R with the Zener diode in a reverse bias arrangement. A load resistance is connected parallel to the Zener diode to collect the constant voltage output across it. The current through R is equal to the sum of the Zener current and load current. If the input voltage in the circuit is increased, the current through R and the Zener diode increases. This causes an increase in voltage across R without a change in voltage across the Zener diode. This is due to the fact that beyond the breakdown voltage, the voltage across the Zener diode remains the same, although the current through it changes. On the other hand, if the input voltage is decreased, the current through R and the Zener diode decreases. This reduces the voltage across R without affecting the voltage across the Zener diode. Thus, irrespective of increase or decrease in the input voltage, the voltage across the Zener diode remains constant, which is collected across the load resistance. Hence, the Zener diode acts like a voltage regulator. The choice of the Zener diode depends on the required output voltage. Zener diodes are available with output voltages ranging from a few volts to hundreds of volts. In order to provide good voltage regulation, it is essential that the current through the Zener diode is several times higher than the load current. This is done by selecting a suitable series resistance R that ensures Zener current in the circuit is several times higher than the load current. You have now reached the end of this module. In this module, you learned that the voltage at which there is a sudden increase in current in a reverse biased diode is called the breakdown voltage. A diode designed to have low breakdown voltage under reverse bias is called a Zener diode. The voltage across a Zener diode remains constant, although the current through it varies widely. A Zener diode can be used as a voltage regulator to convert a variable voltage input into a constant voltage output.